Okay, we'll look at some recursive sequence here. So here we have our first term is equal to 1, so a sub 1 is equal to 1. Our general term is equal to the term number minus the previous term. So this is the nth term, so this is the previous term, a sub n minus 1. So this is a subscript. This is not a times n minus 1. This is a subscript, just like this is a subscript. So it's like a notation. So if a sub 1 is equal to 1, so so we already know 1, and notice it says n is bigger than or equal to 2, because we already know the first. So therefore, a sub 2 is equal to wherever I see n, I put a 2. So a sub 2 is equal to, and I put a 2 there where I see n, so 2 minus a sub 2 minus 1 equals a sub 2 minus 1 is 1. Oops, sorry. That should be n. So this is n. Last time. That is 2. We already know that. That's 2. So 2 minus the first term, which is 1, equals 1. So now our third term is wherever I see n, I put 3. So 3 minus a sub 3 minus 1 equals 3 minus a sub 2 equals 3 minus a sub 2 is equal to 1. So it's equal to 2. A sub 4 is equal to 4 minus a sub 4 minus 1, which equals 4 minus a sub 3, which is equal to 4 minus a sub 3 is equal to 2, which is 2. And lastly, it says find the first 5 terms. So a sub 5 is 5, because n is 5. A sub 5 minus 1, which is 5 minus a sub 4. So 5 minus a sub 4 is equal to 2 equals 3. So let's look at our graphing calculator and do the same thing. Normally we're in function mode when I hit y equals. We're in function mode. We want to use a different mode. We want to use the sequence mode. Later on in the year we'll look at both parametric and polar, but right now we're just going to look at the sequence mode. So I just go down and over to sequence, and now I go back to y equals, and notice that it looks a little bit different. As opposed to having y equals, we now have u. Our functions are u. So this is our definition of the sequence is u of n, so n is our variable. Notice here it says x, t, theta, n. X denotes when you're talking about functions. T denotes when you're talking about parametrics, which we'll look at later. Theta denotes when you're looking at polar, and n talks about when you're talking about sequences. So we want to use, so our definition is n minus the previous term. N minus the previous term. So n, there's n. We want to do minus the previous term. Well, notice right there, there's a u. Okay, so that's the same as this u right here. So there's a v, and that's that v right there. So if we have a different function, we'll use v. And if we have w, we'll have that function right there, w. Okay, so it'd be u. And then when you use parentheses, it's implied that that is your subscript. So that's the same thing as n minus a sub n minus 1. N minus a sub n minus 1. This is our first term. Our first term in this case is equal to, what is it, 1? 1. So we got to put 1 in there. So we just put 1, press enter. So now we go to, I want to set the table, and I want to start at 1. And I want to increment by 1 because each term goes up by 1. A sub 1, A sub 2, A sub 3. We'll leave them both on auto. That's fine. So pressing enter, I didn't really need to do that. So now let's go to the table. So second graph. And now here are our terms. So 1, 1, 2, 2, 3, 3, 4, 4. So this is kind of a cool sequence because it repeats itself. 4, 4, 5, 5, 6, 6. There you go. Okay, so that's kind of a pretty neat sequence, pretty neat recursive sequence. Okay, so here's all the keys that I pressed. The main one is that you want to make sure that you put it in sequence mode, and that if you're talking about the u function, you use second 7, and if you're talking about the v function, you'd use second v. And let's see what other, you have w, and that's it. So there's only 3 functions, u, v, and w. Okay, Let's look at our second recursive sequence. So let's just scroll down here. Sorry, my computer is auto-saving. This one's a little bit different. We have two first terms, namely a sub 1 and a sub 2 is negative 1 and 1 respectively. And then our nth term is equal to a sub n minus 2. So that in that case, if we're doing a sub 3, this would be a sub 1. And then the term number times the previous term. So this is 2 away, and this is 1 away. Notice that says n is greater than or equal to 3 because we already know a sub 1 and a sub 2. So a sub 3 is equal to, so a sub n minus 2, so that would be a sub 3 minus 2, plus the term number, which is 3, times a sub 3 minus 1. So that's a sub 1 plus 3 times a sub 2. A sub 1 in this case is negative 1, plus 3 times a sub 2 is 1. 3 times, was that 3 times 1? 3 times a sub 2 is 1, so let's erase that. 1, so that's negative 1 plus 3, which is equal to 2. A sub 4 is equal to a sub 4 minus 2 plus 4 times a sub 4 minus 1. So that's a sub 2 plus 4 times a sub 3. A sub 2 in this case is 1 plus 4 times a sub 3, which is equal to 2. So that's 1 plus 8, which is equal to 9. A sub 5 is equal to a sub 5 minus 2 plus 5 times a sub 5 minus 1, which is a sub 3 plus 5 times a sub 4. So a sub 3 we already know is 2. A sub 4 is 9. So that's 2 plus 45, which is equal to 47. We want to have 6 more terms, so we've already done 3. So here's our fourth term, which is a sub 6 minus 2 plus 6 times a sub 6 minus 1, which is a sub 4 plus 6 times a sub 5. A sub 4 in this case is 9 plus 6 times a sub 5, which is 47. I already did this work out, so I'm just going to write down the answer. I don't feel like doing the multiplication. 291. A sub 7 is a sub 7 minus 2 plus 7 times a sub 7 minus 1, which is equal to a sub 5 plus 7 times a sub 6. A sub 5 is equal to 47 plus 7 times 291, which that is equal to 2084. So again, our first term, is negative 1, second term is 1, and then it's the two previous terms, this term number times the previous term. So let's go back to y equals. I'm going to clear out the history. And let's go back to y equals, which were there. So, oops. I've always had n sub n be equal to 1, so we'll not worry about that. And let's clear the history again. So our definition is a sub n minus 2. So that would be u of n minus 2, close parentheses, plus, I believe it's the term number times the previous. So n times u sub n minus 1. So now this is what is the initial term. Well, in this case, we don't have initial term, we have initial terms. And the strange thing in TI is that when you write out using recursive and you have more than one initial term, you have to put the two terms in curly brackets and you must put them in reverse order. So this is going to be curly bracket 1, negative 1. So curly brackets are second y equals 1, comma, negative 1. Close curly brace. So you have to put the curly braces in when you have more than one initial term. If you only have one initial term, then you don't need to put the curly braces, and you need to put them in reverse order. I don't get it either. Let's go to table set. I'm going to start at 1 and go up by 1. and then let's go to table, and then here are our values. So -1, 2, 9, 47, 20, 48, and so on. Okay, gets pretty big, pretty fast. All right, so that's how you use the graphing calculator to do recursive sequences, as well as doing recursive sequences without a calculator.